Building on solution architecture design, you now zoom into the part of enterprise change that causes the most delays, the most defects, and the most blame when things go wrong. Integration is where systems meet and where assumptions collide. If your integration boundaries are unclear, your scalable and supportable solution can still fail in production because the interfaces are fragile, undocumented, or inconsistently implemented. An interface control document is how you turn integration from guesswork into an agreed contract. With that importance clear, you should treat an interface control document as a contract of responsibility, not as a technical appendix. It defines how two or more systems interact, what data moves between them, what rules apply to that data, and what each side is accountable for. The purpose is not to document every technical detail. The purpose is to remove ambiguity, reduce integration risk, and make cross-team delivery predictable. Now that you know what it is, you can explain why interface control documents exist without sounding process heavy. In large organizations, integration often spans multiple teams, vendors, and programs. Without a shared contract, each party builds based on assumptions, and those assumptions only surface when the solution fails during testing or after go live. An interface control document creates a shared truth that governance can review, delivery can implement, and operations can support. With the value established, you now place interface control documents inside the bigger integration architecture story. Integration architecture is how you design the enterprise nervous system, meaning how applications communicate, how data flows, and how changes remain safe as complexity grows. Your interface control documents are the enforceable links inside that system, turning high-level integration patterns into specific owned, testable contracts. With integration architecture in mind, you now adopt the mindset that makes interface control documents successful. You are not trying to impress anyone with complexity. You are trying to make two parties agree on what must be true for the interface to work reliably. When clarity wins, delivery speeds up, incidents reduce, and future changes become safer because teams know what they are changing. With the clarity mindset set, you begin every interface control document with ownership. You define the producer and the consumer, and you make it explicit who owns which responsibilities, such as schema ownership, validation rules, availability commitments, and change approval. Without ownership, integration becomes a shared problem that no one truly owns, and shared problems become future outages. With ownership clear, you now define purpose so the interface is tied to outcomes rather than being treated as plumbing. You describe what business capability the interface enables, what use cases depend on it, and what happens if it fails. This makes the interface control document decision ready because leaders can understand its business criticality and prioritize investment in reliability and security accordingly. With purpose defined, you now make data flows explicit. You describe what data moves across the interface, whether it is real-time or batch, the direction of flow, the triggers, and the expected volumes. You also highlight sensitive data and critical data because data sensitivity changes security requirements and compliance expectations. When data flow is clear, risks become visible and design choices become defensible. With data flow visible, you now define the data contract, which is one of the most important parts of an interface control document. A data contract describes fields, types, required attributes, validation rules, and business meaning. It also defines how errors are handled, how missing data is treated, and how the interface avoids creating inconsistent versions of truth across systems. This is how you prevent the common enterprise problem where different systems interpret the same data differently. With data contracts covered, you now explain what an application programming interface contract means in practical terms. You define what operations exist, what inputs are accepted, what outputs are returned, and what response codes and error messages mean. You also define idempotency expectations, meaning what happens if the same request is repeated, because repetition is common during retries and failure recovery. This creates predictability and reduces integration defects that only appear under load or during outages. With the interface shape defined, you now address non-functional requirements because interfaces fail as much from non-functional gaps as from functional mistakes. You define availability expectations, performance expectations, capacity expectations, and timeout expectations. You also define what happens under stress, such as rate limiting behavior and back pressure behavior, so the interface fails gracefully rather than collapsing unpredictably. These requirements are what make integration survivable in the real world. With non-functional requirements in place, you now embed security controls into the interface control document. You define how authentication and authorization are enforced, what trust boundary exists between systems, and how sensitive data is protected in transit and at rest. You also define logging and monitoring expectations, because without visibility, interface failures become long incidents and security events become invisible. This ensures integration does not become the weakest link in your security posture. With security embedded, you now solve one of the biggest enterprise integration problems: change over time. You define how the interface will be versioned, how changes will be communicated, how long old versions will be supported, and how deprecation will occur safely. You also define compatibility rules, because uncontrolled breaking changes are one of the fastest ways to destroy delivery velocity across portfolios. A strong interface control document protects the enterprise from future change chaos. With change management set, you now make the contract verifiable without going into hands-on detail. You define what must be proven, such as schema validation, error handling, performance under expected load, and security control effectiveness. You also ensure that interface assurance is included in governance checkpoints, so integration risk is reviewed early and not discovered late. This is how interface control documents support architecture assurance from initiation through sustainment. With verification covered, you now ensure the interface is supportable after go live. You define monitoring expectations, alerting triggers, logging requirements, and how incidents are triaged across producer and consumer teams. You also define who is on call, how escalation works, and what service levels are expected. Interfaces do not fail politely, so your support model must be clear before production. With the structure clear, you can now ground it in a realistic enterprise scenario. Imagine a digital customer services platform that needs customer identity data, billing status, and communications preferences. These come from different systems owned by different teams. Your interface control document defines which system is the source of truth for each data element, how the digital platform requests data, how responses are structured, and how errors are handled when a downstream system is unavailable. You define security controls to ensure sensitive customer information is protected, and you define versioning rules so future changes do not break customer journeys. Because the contract is clear, delivery teams can build confidently, governance can assure risk controls, and operations can support the integration when real-world failures happen. As you close the lecture, you should recognize why interface control documents sometimes exist but still fail to prevent integration chaos. They fail when ownership is unclear, when the document is too vague to be enforceable, when versioning is missing, and when non-functional requirements are ignored. They also fail when the interface contract is written once and never governed, causing drift between what is documented and what is implemented. You avoid these failures by treating the document as a living contract tied to governance, assurance, and operational support. Let's now discuss the key takeaways from what you learned so far, so you can use interface control documents to reduce integration risk and speed up delivery. An interface control document is a contract that removes ambiguity by defining ownership, purpose, data flows, and responsibilities between systems. You make integration architecture reliable by turning high-level patterns into specific, testable interface contract that delivery teams can implement consistently. A strong interface control document defines data contracts and application programming interface contracts clearly, including validation rules, error handling, and idempotency expectations. You include non-functional requirements, security controls, and monitoring expectations, so interfaces remain reliable, secure, and supportable in production. Versioning and change management protect the enterprise from breaking changes that destroy delivery velocity across portfolios. When interface control documents are governed and assured across the life cycle, integration becomes predictable, scalable, and safe. As you move into the next lecture, start treating interfaces as enterprise contracts, not informal connections between systems. Subscribe to the channel so you do not miss the next videos in this playlist. Like this video, so it reaches more leaders and architects who want to reduce integration chaos and improve delivery speed. Comment with the biggest integration challenge you face, whether it is unclear ownership, data inconsistency, fragile interfaces, or breaking changes across teams. Share this video with someone working on integration-heavy programs, because strong interface control documents are one of the simplest ways to prevent expensive failure later.